Hello everyone. Today and going forward in the next upcoming videos, I will be discussing few topics of calculus, both limit, differential calculus and integral calculus. Today I am going to show you how to evaluate this expression of limit. Limit x tends to 0, tan x minus sin x by x cube. I shall be using some basic formula for getting this derived. So for deriving this, I am writing this expression as limit x tends to 0, tan x I am writing as sin x by cos x, and it is minus sin x in the numerator divided by x cube, right? So from the next step, limit x tends to 0, if I take common sin x, then it is 1 by cos x minus 1 divided by, I can write x into x square. I have segregated x cube as x into x square. So from the basic formulas of limit, we know that if two expressions are there, two functions are there, and their product is under the limiting expression, then I can write it as limit x tends to 0 sin x by x. I am just separating it out into two different functions, into limit x tends to 0 1 by cos x minus 1 divided by x square. So this part I have considered as a separate function, and another part I have kept it as another function. Now you know from the basic formula of limit, this is evaluated as 1, right? So my only remaining portion is this one. What is that? Limit x tends to 0 1 by cos x minus 1 divided by x square. So I am keeping this part only and removing the existing section. Let us check how we can further derive the value of this expression. Equal to, I am just writing it over here, limit x tends to 0 1 minus cos x by x square cos x. Just it is a subtraction of fractions as we do for normal numbers. Now same can be written as limit x tends to 0 1 minus cos x is nothing but 2 sin square x by 2 divided by x square cos x, right? Now if x tends to 0, then obviously x by 2 can also tends to 0. So the same expression I am writing over here as limit x tends to 0. Again I am separating it out as 2 comes out of the limiting expression because this is a constant. 1 by cos x I am taking it as a separate function, and secondly limit x tends to 0 sin square x by 2 divided by x square, right? So what I have done, I have taken 2 out of the limiting expression because this is devoid of any expression of the variable x, so it comes out of the limit. 1 by cos x I am separating it as a separate function, and the remaining portion I am kept it in another limiting expression. So 2 limiting expressions are multiplied and 2 is getting out of the limit. So cos 0 is 1, so it becomes 1, 2 into 1 into limit x by x tends to 0. So if x tends to 0, then I can also write x by 2 also tends to 0, right? So I can write it as sin square x by 2, and similarly I am writing as x by 2 whole square in the denominator. But keep in mind that x by 2 whole square, when I am keeping it, 4 is getting generated at the denominator. So neutralize, I have to keep another 4 in the upside of the denominator. So here it becomes to 2 as I have got it. So finally the expression becomes 2 into limit x by 2 tends to 0 sin square x by 2 can be written as sin x by 2 into sin x by 2 divided by x by 2 into x by 2, right? Because x square by 4 can be written as x by 2 into x by 2. Also 4 is there, so 4 can come out of the limiting expression as it is devoid of any value of x. So my final answer will be 2 by 4, that is 1 by 2 will be the constant part of the expression that I am getting as a final answer. So it becomes 1 by 2 outside of the limiting expression. Limit x by 2 tends to 0, then sin x by 2 divided by x by 2 into same expression once again, limit x by 2 tends to 0, sin x by 2 by x by 2. Now from the basic formula of limits we know that this expression is evaluated as 1. If I consider x by 2 as y, then it is simply limit y tends to 0 sin y by y. Same for here also. So this expression is also getting evaluated as 1. So this one is also 1. Why? Because we know that limit y tends to 0 sin y by y is the basic formula of limit, and that is evaluated as 1. So the final answer is half into 1, that is half. So this is a process of getting the answers for limits of trigonometric functions, and I will be showing you different types of limiting expressions, how they are going to be evaluated in the upcoming next videos, and different chapters of calculus, both differential and integral. Meanwhile, if you like this video, I will request everyone to view, watch and subscribe my channel. Thank you.